But before we start, I need to say something and I need to check something with you guys. So actually, I have a challenge. I have a project to be developed. It's very time strict. And I've been hearing a lot of voices telling me that you should go with JavaScript for the backend. But I'm confused. I don't know. I don't really know what to do. So can you guys help me? What should I do? What?
Hello.
Who are you guys?
I'm your good conscience.
What?
No, I am your good conscience.
What is this? What should I do?
Yeah, have faith in JavaScript. Give it a chance.
Man,
It's
don't
all
throw away
around
your
there.
soul.
Guys, well, again,
Unless you want to go back to hell with me.
guys, thanks for nothing, huh? Thanks for nothing.
Why did you do that? What do you have against JavaScript?
Well, I will just share with you right now. I'll start first with sharing a little bit about JavaScript history, which is quite strange. So JavaScript was created in just 10 days. It really feels like a hack by Brendan Eich for Netscape Navigator, which purpose of enhancing static web pages with dynamic content by scripting and embed and communicate with Java applets. Just 10 days, guys. What good can come out of it?
Well, you know, our father did something bigger in just 6 days, remember?
Well, but I have more, right? Node.js also has a strange history. It was ported from V8 JavaScript engine from Google Chrome to Linux, created by Ryan Dahl in 2009. And in 2010, NPM was created to host and distribute modules. From here on, guys, I think you guys know what happened, right? Hell break loose.
1990, HTML is invented. 94, CSS invented to fix HTML. 95, JavaScript invented to fix HTML and CSS. 06, jQuery invented to fix JavaScript. 2010, AngularJS invented to fix jQuery. 2013, React invented to fix AngularJS. 2014, Vue invented to fix React and Angular. 2016, Angular 2 invented to fix Angular. 2017, WebAssembly invented to fix this madness. 2019, Svelte invented to fix React, Angular, and Vue. React hooks invented to fix React. 2020, Vue composition invented to fix React hooks. Solid invented to fix React, Angular, Svelte, and Vue. HTMX invented to fix React, Angular, Svelte, Vue, and Solid. 2021, React suspense invented to fix React again. 2023, Svelte runes invented to fix Svelte. 2024, jQuery is still used on 75% of websites.
75% of websites.
Very funny, very, very funny. You know what? Let me enlighten you.
Ooh.
Because history really doesn't matter. I mean, Java was created for a different purpose than it is used now, right? It was actually invented for the use in interactive television. So basically used on set-top boxes with a minimal infrastructure. And now it's running quite a big share of server applications in the world. And there are more examples. Python was created for Amoeba OS, which was basically a distributed operating system. So in that time, it was common to have pools of computers, and Amoeba OS was designed to have all of the single-core computers work as one big multi-core computer. And this was discontinued later. And you know, now Python used in data science, machine learning, web development, and so on. And I have a third one, Lua, which was created as a scripting language for embedded systems or for embedding in other applications, basically. It was used there, but now it is really, really big in gaming. So do you think history is that important?
Okay, I give you that. Maybe it doesn't matter, but I also heard that Haha, JavaScript is single-threaded. It can only execute one piece of JS at a time. And there is no parallel execution of JavaScript code because of the event loop. So that said, when you want to downgrade your backend speed so much, you might as well run your server on a calculator supplied by potatoes. So, Antonio, if that's what you want to do in your project, it's up to you. And by the way, when Dahl presented Node.js, he was really motivated about the event loop.
But yeah, luckily JavaScript was designed in such a way that it was built for an event loop. The browser side JavaScript that you have is an event loop. You create a button. Somebody clicks it, you get an on-click callback. This is exactly what one needs to do event loop stuff.
Okay, guys, so this was the creator of Node.js in 2009. And guess what? 9 years later.
And it's my fault, and I'm very sorry. And unfortunately, it's impossible to undo now.
That's out of context.
Yeah, that's what I'm saying. Are you not taking this out of context here?
Called the Andrew line. Of course, I'm trying to make an argument here.
This is how they do it at your place, right? Yeah. Yeah, do you even know what an event loop is?
No, explain.
Yeah, let me explain. What makes JavaScript so special? Because JavaScript is a single-threaded, non-blocking, asynchronous concurrent language. In other words, just JavaScript runtime runs Java code in a single thread, but provides concurrency via asynchronity in a non-blocking way through the runtime by using an event loop.
Who understood what he just said? Anyone here?
Well, it is best explained by looking at the actual architecture of the runtime. So you have here a typical system of the JavaScript runtime, which consists of the JavaScript VM you can see in gray here on the left. This has a heap and a stack, and yes, it has just a single thread. The runtime also provides APIs like HTTP requests, timeouts, and document manipulation. And in case of the server-side JavaScript with Node.js, we also have access to file system APIs and process APIs, which of course then on Node.js, you don't have access to any document because it doesn't exist there. So this is the change. And the left side, the VM, is basically both the same. As you said earlier, Dahl ported the V8 engine from Google Chrome for Linux as to be used in Node.js. And then we also have components in red here, which is the task queue and the green thing there. You see the green thing? That is the event loop, which is basically just a process with a specific task. When you now, from the stack where your instructions are, and you call a function, an API function like setTimeout, for example, you give it a callback, and then the runtime takes care of everything else. Then the VM will continue non-blocking to execute other things. This is the non-blocking part of it. Then when the timeout is reached, the runtime will take care of pushing your callback onto the task queue. Still, your VM does not really know what is happening here, but the event loop then takes care whenever the stack is empty, it will take one task out of the task queue and push it back onto the stack to be executed.
Well, before I ask you a question, this really looks for me that you used Paint for this. So why should I believe you in anything what we are saying?
I wanted to make it simple and yeah, Comic Sans and Paint-like structures, the best for presentations.
Okay. So what you mean is, as a result, I should put tasks into the runtime and not do them in the JavaScript VM?
Yeah, that's exactly what you should do. And there's a lot of ways to do that. I mean, for example, you can just offload all of your work to different servers. What you do on your daily basis, I hope, you call other APIs via REST, GraphQL, remote procedure calls, however you name it. For example, like this, there's an API for getting jokes. Want to see one?
Yeah, go for it.
That any good? Maybe the next one will work for you.
Do you want more? One more joke?
Let's go, one more joke. Huh. Yeah.
That's a good one.
Okay. What you can also do is you can use workers. Workers are designed to run JavaScript in a separate thread, and the separate thread then communicates with the main thread via message passing. Again, via the event loop, those messages get worked up in the main process, and then you can communicate back with the with the worker also via message passing. And those flavors are available for the browser. They're called web workers, if you're ever going to search for this. And in Node.js environments, they're called worker threads. Yeah, and just as this is an JavaScript web application, I can just start a worker that counts from 1 to 10. And I can also just start multiple workers that will then eventually finish after they do their work. So it's really easy, just offloading JavaScript. And what's also cool to do, you can use WebAssembly. So apart from the previous example where we ran actual JavaScript, maybe you want to program in a different language. And WebAssembly is there for this purpose. It's a low-level bytecode that runs then in the browser in Node.js environments. So it's pretty flexible. I have an example here. Might be a bit hard to read, but please bear with me. I'm declaring here a function, which is also exported, called add. It will then have 2 parameters of the length of an integer of 32 bits. And this function will return a result of an integer with 32 bits. And what it does is basically, it will get the first and the second argument from the stack, and then invoke the function add of 32-bit integers. So really, really simple. Let me demonstrate it like, I don't know, 2 plus 3, and it works. Of course, because it's so simple, it will not handle errors. This is really just to get the idea of it.
And do you expect me to write code like this?
Oh, no, not at all. This is just WebAssembly text. It's there, as I said earlier, it's a bytecode that runs in the browser, and WebAssembly text is the easiest way to make this visible so that you can actually kind of get the idea what is going on. And of course, there's compilers for WebAssembly for all of the major languages. Rust, C, C++, and Go, I think, have production-ready WebAssembly compilers, and there's loads of other that just compile to WebAssembly, which you then can run. And of course, if we're talking about backend, we can also just use C++ code, so the language where Node.js is written in, to extend it and provide some APIs that we then can call from JavaScript. So for example, if you have to have access to a very, very low-level system API in your server environment, you can just use this trick.
No example this time?
No. C++ examples get very big very quickly, and they are really hard to read. So, and besides, we can't even run them here because this is a browser-side application, and everything here is sandboxed, so you cannot really do anything here. I'm sorry. So yeah, it's really easy. JavaScript is single-threaded, yes, but you just have to offload your code to somewhere. And yeah, those are the ways to do that. Call APIs, use workers, use WebAssembly or native code if you want to.
Okay, so now I see how JavaScript is supposed to be used, but I'm still not convinced. And I think I will get some supporters on the next slide.
Oh.
So if you just have 2 plus 1, of course, 2 as a string and 1 as a number, you actually get 21. But then if you do 2 minus 1, you get 1. What do you have to say about that? No words. Okay, I'll go to the next one. So actually there is an equal operator that behaves really strange. So if we see a comparison there, so an empty array and 0, then 0 string and 0, and we see that both of them are true. But this operator is not symmetric. As you can see now, I compare an empty array with a 0 string and it's false. I'm not done yet.
No.
So if you add just a couple of characters, guess what?
Strengths.
I get bananas. And now I need to do some clicking. So if I run this code, it will run, but I get undefined. And now, Angel, I need to edit this.
Yes.
Jesus.
You want
What's
to comment?
going-
You want to comment out the line?
Yes,
Okay,
thank
let
you
me
very
help you
much.
with that.
Okay,
Yeah.
so let's just skip. I'm not even going to try to fix this. Thank you, Angel. Okay, I love this one. So I have a sorted array, and then I sort it, and guess what? I get unsorted. That's strange, guys, right?
Okay.
Do you have
okay.
anything to save these arguments?
Yeah, I mean, those are very good examples, right? JavaScript has kind of a dark side. But you know, anything that is wild can be tamed. And let me just show you by going into an editor. So what you see here is VS Code for the web, available via GitHub in code spaces. This is actually an IDE written in JavaScript. Just to making a point, are you impressed any bit?
Not yet, but show me whatever you are going to show.
Yeah, what you will slowly see right here is what we use in projects. We're actually using linters to help us fix our problems. And everything you just showed me is actually a problem. So let's just go it one by one, right? So you have the 2 + 1, and you will actually get a warning from ESLint that you're doing an unexpected string concatenation. Because why would you just add this here? I mean, those are constants, right? So in the easiest way, you could just write here and there, right? But if you have a variable, you can then just use actual string concatenation somewhere like that. Or maybe I should just use fixers, because we also have something like that, where we can use something like that, right? Template string, now everything's fine. Second example, TypeScript is actually asking me, why are you subtracting from a string? This must be number, big int, or any. Why are you exactly using a string here, right? So this might actually be that you would wanted to call an actual conversion first. So it doesn't give me an example here, but I can just explicitly make this a number first. And then this should also work. Yeah, we have kind of a black sheep in JavaScript, which is called the abstract equality. There's an easy solution, just don't use it, right? So all of those examples you will never really see in the real world unless you actually want to. And then you probably have a statement above that line, saying ignore ESLint for this line. So all of those, I will not accept those as examples. Yeah. So here with the bananas, this is actually like a classic you see all over as a critique on the internet. And this is basically the trick that happened here. So double plus signs and an A, which is an implicit coercion. Basically, what JavaScript is trying to do here is parsing A as a number, which is, of course, not a number. And this is where the not a number is coming from. So, and of course, the remainders are just characters, right? This example, I'm almost finished. Please bear with me. This example is a funny one. It's kind of a thing that was a thing in JavaScript before it matured. So you could, for example, have your JavaScript in a whole file. You could define functions that would access global variables that you can then declare later. So what JavaScript did, it hoisted those variables, which means it declared them before their use. So what is actually happening here? It would do something like this and put the declaration here. So that means now A is defined as a variable, but doesn't have a value. So console log will actually put undefined. And then, of course, the assignment comes later. So this was the reason behind that. Modern JavaScript developers just have an answer that is, again, an ESLint rule. Just don't use var. Use let for mutable state, use const for immutable state. And the last example, yeah, this is also kind of an old thing in JavaScript. If you call sort on an array, it will convert all of the entries to a string first and then sort them lexicographically. So in this case, it makes total sense that you are having the ones first, then the 2, then the 5, and then the 8s, right? What you actually want is you want to call sort in any way. You want to call sort with an explicit method of what is to be done here. So in this case, maybe A, B, B minus A, right?
I would say so.
So it's easy. JavaScript can be tamed. So let's go back to our presentation. Because I want to show you even more good things about JavaScript, right?
Go for it.
First, some more notes about ESLint. ESLint is a linter for JavaScript, TypeScript, templates for various languages. So if you're using React, it will go through your templates. If you're using Angular, it will go through your templates. It doesn't even make a break before Vue templates. It will just work. And there's plugins for more and more and more. You can actually create custom rules for your custom code style guides. So if you have if your engineers came up with a construct that is only common to your project and you want to enforce it over multiple files or multiple projects, or just in your single project, you can actually develop an ESLint rule for that. In my past, I was readily doing that for a big project, and boy, did my fellow developers love me for that. ESLint also integrates with most editors. And if not, it just runs from the command line where you can have it available as a pre-commit hook. So to prevent erroneous code being checked into your repository. And you can also provide fixes for rules. I think I showed one of them, did I? I can't remember. But there are fixable rules, and they will just run through your project and fix what is, without a doubt, the better solution than your solution. And what did you use as a code formatter in your last project? I'm just wondering.
Well, nothing really. We just use the default code style from our IDE. The devil loves messy stuff.
Wow. Yeah, I was afraid of that. In the JavaScript world, we have Prettier because Prettier is your friend. It's an opinionated code formatter for JavaScript, TypeScript, HTML, CSS, and, plugins. You can format whatever you want. And it will also integrate with most of your editors or ESLint directly. You can call it from the command line in your CI process. Everything is just fine. How do you like that?
So no more arguments about where the curly braces go?
Not in our world. And now let's come to some features that make JavaScript a bit unique. JavaScript has a concept of truthy and falsy. So you see the values here: 0, not a number, an empty string, null, undefined, and false are all considered falsy. Everything else is truthy. So if you have, for example, you're working with forms on an HTML form and you have your JavaScript snippet, you don't have to check if it's undefined or if it's an empty string or if it was a number input, if it's 0 or if it's null. No, you can just check, is there a value? Because having an actual value is considered truthy. And then you have your simple if statement that will just execute. There is things like optional chaining. So I'm using a TypeScript example here. Let's say I have a user with a name and an optional address. And this address can then have an optional country, for example. And if I have a user object that obeys to this interface, and I'm creating it without an address, I can still just have this line here with the optional chaining operator. And yeah, this type will now be string or undefined. And there's even an ESLint rule that will make sure that you're not overusing this feature.
Okay, that's nothing special. We have something like that in Kotlin or C#.
Yeah.
And if I remember correctly, this was even introduced earlier than JavaScript.
Yeah, that might be true. It's still not available in Java though, right? How about this one? Nullish coalescing. Basically, I'm using the same address here. Also the same user without an address. And now I'm invoking the nullish coalescing operator. So that means whenever the left side of this operation is null, undefined, it will automatically take the right side. So in this case, the city variable will be string ever, and it will be defined.
It's also something that is not new. So can you give me something at least that is just JavaScript?
Okay, now you want it. Let's go to a real example now. TypeScript has a really awesome way of type inference. So for example, I have an array of event types. Let's call them click mouse over. This is standard stuff we use in the front end. And then we can just create utility types for things that we want. For example, if we want to infer the generic type of the array into a type, we can use this utility type. It uses a bit of a complex declaration, but as anything, if you get used to it, you will be able to read it more fluently. For now, let's just say I can use this utility type to be used on another type. In this case, I want to infer the types of the event types. So then I can use them in an implementation. So might be a bit complex. Let me just hover a bit. So for example, I have event types, which is a string array here. And then my infer array type will infer strings, which I then can use here in this function parameter and of course in this switch statement. If I now, for example, go ahead and let's just add a 3, then it will just infer string or number, which again, the event type will then be string or number. And I can then easily just create case statements here that also conform to this. Just like that, for example. The problem, however, with just having string or number means, yeah, I can also just do this and it will perfectly compile. So TypeScript has an awesome thing called the const operator, which was introduced fairly recently, I would say. So now let's look at the same example again. Event types is now the literal types. So we are having click, mouse over, and 3 as actual types. Event type again, click, mouse over, 3. And it means my 4 is now no longer conforming to this type. And look at that. I made a typo. Didn't know that. Is that something special, I guess?
Hey, yeah, it looks good.
Okay. We also have duck typing. You know the concept? If it walks like a duck and quacks like a duck, it is a duck. So here are 3 examples on how to actually create objects that conform to a specific structure. I have a type definition, name H for a user, and an object user that conforms to it. I have a car, that's actually an interface, and an object that conforms to it, with name and model as strings. And then here I have a class, monument, which has a public field, name, as a string. And yeah, the Eiffel Tower as one of the instances of that monument. I can then, of course, go ahead. All of those have a name. I can just use a union type and have a print name method, which does something with the name. And this should be callable quite easily. So, but this is not really duck typing. You would do in some other languages, you would always have to have some kind of common type definition that all of those fields have in common. In this case, you would, in JavaScript, you would use a union type. So in TypeScript, of course, you would use a union type for that. But you can just make it easier. You can just duck type and say, hey, I'm only interested in name as a string. So, and then everything is still callable. To prove you another example, let's just say I'm using model as a string. So only the car should now be callable. And of course, I get arrows for the other ones. So you can just create types as you need them. You don't need to introduce abstract interfaces or anything like that. So TypeScript is really awesome. Yeah, and it doesn't stop there, right? So you can see here an example with types of literal types of area and arrows. Let's just say I have browsing, checkout, and login. I'm obviously developing a shop. And I have arrows like not found or unauthorized. I can then create other string literal types by using template strings. So this that can then be filtered or even extracted out of. Again, let me show you by hovering over all of this. You see, area arrow now is a combination of all of them. So I have browsing, not found, browsing unauthorized, and so on. And then I can exclude certain specific literal types with this. So now from 6, we are just down to 4. And I can also use extract on original types and reconstruct a literal type to then filter out even more. And yeah, filtered area arrow 2 now only has 3 types. So, and this works in type checking. So if I assign types now, let's just say we are creating something from here. The IDE will support me. I have IDE support for whatever I'm doing here with my literal types. And yeah, checkout is not part in the second filtering process, so I will also get an error. Amazing feature, isn't it?
Yeah.
So TypeScript as a superset of JavaScript. So basically this means every JavaScript file is automatically a TypeScript file, but adds, of course, type information for it. And there's so many unique features that add proper types to your code. In the long term, you can see TypeScript today might be the JavaScript of tomorrow. This has been mostly the case that usually features enrich JavaScript after they are tested out in TypeScript. And yeah, use ESLint or Prettier to keep your code clean. Is there another topic?
Well, I have to confess that I'm learning a lot. I'm running out of arguments, but I saved my favorite for last. Haha! So you guys probably know what node modules are. They are the heaviest object in the universe. And when you actually try to download every module or library in the internet, you also get unknown sources, vulnerabilities. And how can you actually deal with that in JavaScript?
Yeah, I mean, the problem itself first, right? It's not really unique to JavaScript, right? There's always, when you have bigger projects and you have dependencies, the dependencies are always the problem. Of course, your problem is mostly within your own project, but it could be that there are problems in dependencies. So this is actually, let me maybe show you some examples, right? So recent exploits, one from 2014 and one from 2021. Don't know if you heard about them, but there was Heartbleed, which was a security problem in the OpenSSL library. So I think it was a C project where you do all of the memory management by yourself. And in the extension of the Heartbeat, which is basically a keep alive process in SSL connections, which was problematic in the OpenSSL implementation of that. In that process, the actual attacker could give you a heartbeat signal and request more memory than he was actually allowed to read. So basically, it was a buffer overread that was happening on your side of the server, and you were reading more memory. And in that part of the memory, it was possible that, yeah, data, very sensitive data could have been. And this was then transferred back to the attacker. So a really, really big exploit. It was fixed within a very reasonable time. Of course, it only affected the implementations or the servers that actually use this heartbeat functionality. And probably even now, there are a lot of servers out there who still use a faulty OpenSSL library. And more recent, maybe, there was the log4shell exploit. Also a problem with the most famous logging library in Java processes, the log4j library. It actually made it possible to execute code on the server when somebody made a logging statement that was based on user input. So basically, your user input that you made, maybe on a website, could land unsanitized onto the console, and there it was already executing code for the attacker. Also something that affected a lot of computers, and also something that had to be fixed. So yeah, not really unique to JavaScript, right? And JavaScript answer to all of this is npm audit. It's a built-in tool for checking vulnerabilities. It can be run in CI/CD pipelines or locally whenever you want. And it has a lot of support for explaining the issues that it found with the libraries. And it can automatically fix some of the issues. So you can use npm audit fix to apply non-breaking changes automatically. You should do that before releasing the software and before testing it, because, right, something can always happen. And it can be, like adapted to your needs. Of course, you want to mostly only run the audit on the production dependencies and not on dev dependencies, which are just used for testing. And you can also adjust the audit level. So maybe you know about certain vulnerabilities that are not really important for you, and you just want to have high severity audits running, right? And it really doesn't stop here. This must only be the first point of your audit chain, because there's tools available like Sneak, Socket Security, Dependabot, which probably some of you know from GitHub. And they do a bit more. They check for malware indicators. They are looking at the project itself. Is it maintained enough, or is it not really updated enough anymore? Or even they will look at the code if it is a public library, and they will look for risky patterns, like, are you using JavaScript eval? Are you creating functions from user input? This is really not a good idea, and those projects will tell you that.
Okay, so I have one last argument, an argument that I think my fellow haters, JavaScript haters, will love, and one that also has a special place in my heart. So JavaScript websites are slow. Pages usually use heavy frameworks. A lot of JavaScript is needed to run the pages. And studies show that users will leave if the page takes more than 3 seconds to load. So How will you fix that?
What do you want to do? Run more on the server? I wouldn't say that this is a really good idea. I mean, tooling around web pages has drastically improved in the last decade, so to speak. And web pages just can be optimized. You can use Lighthouse to analyze the performance of your web page. You can even run Lighthouse on backend stuff. Then you can use your frameworks correctly. So read the documentation, configure code splitting, and configure or avoid patterns that are not tree shakeable. This means that your JavaScript bundles will get smaller, your websites will load faster. And then, of course, you can always use CDN to deliver your JavaScript chunks. Chunk them up nicely, deliver only the parts, place them where your users are. It's fairly easy. Of course, this also means you have to configure your caching correctly so that all of your updates are consumed correctly. If there is a library you have as a separate chunk and you're not changing it, why should the chunk change? So caching is very important and to keep a website really running smoothly. And then, of course, there's the frameworks themselves who can help you with pre-rendering stuff. So you can use server-side rendering to render web pages on demand when the user requests it, or you can use static site generation, for example, for about pages or some other static content that will not change until you next build the application. And of course, the initial JavaScript can be reduced. Frameworks like React use server components, and Angular recently introduced incremental hydration so that, for example, you will server-side render components and not transfer the JavaScript to the client because it is not needed there and it's handled as a static component in your browser. So, are there any more doubts?
Well, I think by now I'm not the devil anymore. I'm just a messenger.
Okay. Maybe I convinced you actually. Let's do one thing, okay? Let's come up with a hell-proof tech stack, right? I will ask you questions about areas and you will say, what is the language that we are using, right? Okay, backend. What will you choose?
Elixir.
Elixir. Okay. How about we just stick with TypeScript and Node.js, right? Okay, let's try this again, right? Front end. What will you use?
Elm.
Elm. Okay, now you have me confused. You know, Elixir and Elm are both functional-only languages. Do you want to induce that much pain on any developers?
Yeah, I'm a messenger now, so maybe not.
So maybe we stick with TypeScript and Next.js, right? So that we have a full stack that we can deploy in a monorepo that uses the same tools. Styling?
What about Tailwind CSS?
Oh, amazing. We're on the same page. Static code analysis.
Oh, I love SonarQube.
SonarQube. SonarQube?
Yes.
Have you actually had it active in your last project? You were working with SonarQube, right?
Yeah, and I removed it after one day.
Okay, yeah, I thought as much. I thought as much. In our projects, we run ESLint, of course, integrated with Prettier for formatting everything in our monorepo. And we also have pre-commit hooks that prevent our developers from committing any faulty code. This is what we do. What's for testing? Oh, okay. I see. Yeah, let's use something new. Let's use vtest. Of course, we can always use Jest. At least what matters is that we use the same framework for both ends of our product. That makes it easier for all of our developers to handle everything the same way, to build knowledge the same way. What are we doing about deploying all of our things?
Kubernetes on premises?
Now you really want to induce pain, right? There's still some devil inside of you. Now, we will just use Vercel because it's easy. Everything comes out of the box. And we have support if we want to.
Tony, what do you think? Are you convinced?
I'm getting there. I'm getting.
Shall I take off the
I think so.
horns?
I think so.
Okay. Thank you.